All right, let's dive into one of the absolute cornerstones of electronics, Kirchhoff's current law. You've probably heard of it as KCL, right? And trust me, by the end of this, you're going to see it's way more intuitive than it sounds.
Okay, to get our heads around this, let's forget about electricity for just a second. I want you to picture water pipes meeting in a junction. You've got water flowing in from one pipe, and it's splitting to go out through two others. So here's the question for you. Can that water just poof, vanish right there at the meeting point?
No way, right? Of course not. Your gut tells you that's impossible. You can't just lose water inside the pipes. The total amount of water that enters that junction absolutely has to be the same as the total amount that flows out. It just has nowhere else to go.
And that right there, that simple, gut-feeling idea is the entire secret behind Kirchhoff's current law. Electrical current is just the flow of charge, and it acts exactly like that water. It can't just vanish at a junction. It's really that simple. So before we put the official name on this law, we need to get one little piece of terminology down. In our water example, we kept calling it a junction, while in electronics, we have a specific word for that.
That junction point is called a node. Yep, that's the word. It's just a meeting point, a spot in a circuit where a few different paths or branches come together. You can think of it as a crossroads for current, and it's the most important location for what we're about to do.
Okay, perfect. We've got the water analogy locked in our minds. We know what a node is. Now we're ready for the main event. Let's state the law.
And there it is, the law itself. Kirchhoff's current law tells us that the total amount of current flowing into a node has to be exactly equal to the total current flowing out of that same node. It's a perfect balancing act. I love this because it just cuts through all the formal language. Forget all the long sentences. If you walk away with just one thing today, let it be these two words. Incoming equals outgoing. That's it. That's the whole game. If you can remember that, you've got KCL down.
Okay, theory is one thing, but let's get our hands dirty, right? Let's see this thing in action with some actual numbers. This is where you'll see just how easy this is to use.
So let's imagine we've got this node here, and we take out our meter and we measure the current flowing into it. We find that it's 5 amps. Got it? 5 amps going in.
Now, coming out of that node, the current splits and goes down two different paths. We measure one of those paths and we see 2 amps flowing out. But what about the other one? We don't know what it is yet. Let's just call it I for now. Our job? Find I.
So how do we solve this? Easy. We just use our rule. Step 1, what's the rule? Come on, say it with me. Incoming equals outgoing. Step 2, let's plug in our numbers. The incoming is 5. The outgoing is 2 plus our mystery current I. So our equation is 5 equals 2 plus I. And step 3, well, this is just simple math, right? If 5 equals 2 plus something, that something has to be 3. So our unknown current, I, is 3 amps. See? Simple as that.
Okay, so this works for solving problems, but why does it work? Like always? This isn't just a neat little trick. There's a really fundamental law of the universe that makes it true.
And it all boils down to this one big idea, the conservation of charge. This is a heavy hitter in physics. It basically says you can't create electric charge from nothing, and you can't just make it disappear. It has to go somewhere.
And that's exactly why KCL isn't just a guideline, it's a law. A node isn't some magical box that eats electrons or spits out new ones. It's just a T-junction in the road. And since the charge itself can't be destroyed, the flow of charge, which is what current is, has to be conserved too. Whatever flows in must flow out.
And believe me, this isn't just something you learn for a test. Engineers rely on this every single day. Anytime you've got a circuit that splits into multiple branches, or you're dealing with components in parallel, KCL is the tool you use to make sense of it all. It's the key to unlocking even really complex circuit problems.
All right, let's wrap this up with the key takeaways. What did we learn? 1. Any junction in a circuit is called a node. 2. KCL is the unbreakable rule that says the total current going into that node has to equal the total current coming out. And 3, the absolute easiest way to remember all of this, just 2 words, incoming equals outgoing. If you've got that, you've got KCL. So, we've figured out the rule that governs where the current goes. It's like traffic rules for electrons at an intersection. But that brings up a new question, doesn't it? What's the push that gets the current moving in the first place? What's the engine behind it all? Well, that's a story for another law, and we'll get into that next time.